Hey guys, welcome back. In this video, I want to talk about the time domain equations of our FDM system with cyclic prefix. With respect to cyclic prefix, we have spoken in the earlier videos related to why do we need cyclic prefix, what are the advantages, what are the disadvantages, and how to design the cyclic prefix. So in this video, we will see the time domain equations with cyclic prefix. Okay, so I am getting into my notes here. I hope it is visible. Yeah, all right. So first and foremost thing which we need to consider here is the frequency selective channel. Okay, the wireless channel is frequency selective channel. So which means that we have got multipath components. Okay, and we can represent those multipath tabs as h of 0, h of 1 and h of l minus 1. Basically we have got l paths. Okay, so if this is the case, then how can we write the equations? Let's say for a particular received sample y of n, what we can say is, we can on all these multi paths, um, we will receive some signal, right? So on h of 0, h of 1, like that till the last path. So on h of 0, we will get, let's say, x of let's say this is x of n. Okay, this is x of n. Then on h of 1 we will receive the previous symbol x of previous, you can say, sample, previous sample, x of n minus 1. So like that, on similar lines, if you write for in the lth path, you will get x of n minus l, n minus l plus 1. Okay, so basically, um, when I had spoken about the design of OFDM system, after performing the IFFT, so we will have n samples. We might perform. I mean, we will perform n point FFT, right? So let's say we take n samples in the frequency domain, and let's say we perform IDFT to that. We get the n samples in the time domain. This entire n samples is one OFDM system, right? Like that, we can take the two consecutive blocks of OFDM symbols. So then we have this is first symbol, and this one is a second symbol. Now let us say I am going to transmit this over the channel. Then if we have the L paths, then on first path, uh, let's say I will get x of 0. Then in the first path, I mean the second path, basically h of 1, I should be getting the previous sample, right? So that is what is written over here. Then h of 2 previous to this, so this sample I will get like that. In the lth path I will get like this. So this basically says that, so for the second OFDM symbol, there is an interference from the first OFDM symbol. So this is nothing but the interference from the previous block. So what we can say is this is like inter OFDM block interference. Okay, so inter OFDM block interference. So to remove this only, we had introduced the cyclic prefix, right? So that is the next point. So in order to avoid this interblock OFDM interference, what do we need to do? So we had seen we were adding cyclic prefix. So basically, if this is the this is one OFDM symbol, then I will take the last you know L symbols or L samples, and then I'm going to place it in the beginning. So that is what is done over here. This is nothing but the cyclic prefix. So the length of cyclic prefix also we had earlier spoken about how to design that, so I will not go through that. So basically, considering this, if I'm going to write the net output, so on h of 0, h of 1, h of l minus 1, l path, so I will first path x of 0, so the second path I will have x n minus 1, third path I will have this one, and in the last path I will have basically this one, right? So now it is like we are restricting the ISI to the same block. By introduction of CP, we had some disadvantage that also I have spoken in earlier videos. Considering that into account, what we can say that the ISI is restricted to the same block, and anyway at the receiver we are going to eliminate this much cyclic prefix, right? We will eliminate this because this is affected by interference. Then we will only take these n samples and proceed for our further processing. Similarly, for y of 1, we can write the equations for a y of 1. First one, on the first path, we should get x of 1, okay? Then x of 0 in the next path. So on a similar lines, we can write all the n samples on the n received samples. If you basically look these equations, right? These equations look like the circular convolution, okay? Circular convolution of h and x. That's why we can write it in this form, that is y is equal to h circular convolution with x plus w. Okay, the moment you perform the DFT to this, the circular convolution will become multiplication of DFT of h and DFT of x. Okay, this is a property. So basically, what happens is that with this operation across each subcarrier, you will see that the y of k depends only on this x of k. Okay, it doesn't depend on x of k minus 1 or any of the previous symbol. Okay, so what can we say? There is no ISI. All right. So in the previous video, as I was mentioning, cyclic prefix is like adding the last samples, last few samples to the beginning of the symbol, right? But what could be the other way? Other way is to perform zero padding, right? But there are certain changes or certain disadvantage if you are going for zero padding. So that we will try to see in the next video when I will talk about the matrix form of OFDM. So basically, what it says is like you know once you perform the DFT operations at the receiver, you will get this equations across each subcarrier, and y of k depends only on this x of k, and hence there is no ISI. So this a particular equation, we can say this corresponds to flat feeding channel. So basically, when we had a frequency selective channel with a certain design with certain operations like DFT and IDFT at receiver and the transmitter, we can I mean the effective operation is that it is converting the frequency selective channel into n parallel flat feeding channels, okay, in case of OFDM. So I hope this concept is clear. In this particular video, you had seen how to represent the equations in time domain with cyclic prefix. So we will see in the upcoming video how to represent these equations in a matrix form, and how we can analyze the system better. Okay, thank you very much. Have a great day. Bye bye. If you're looking for more videos, please do subscribe to the channel.